Second problem was 65, and it says astronomers using a 2-meter diameter telescope observe a distant supernova, an exploding star. The telescope's detector records 9.1 times 10 to the negative 11th joules of light energy during the first 10 seconds. It's known that this type of supernova has a visible light power output of 5.0 times 10 to the 37th watts for the first 10 seconds of explosion. How distant is a supernova? Give your answer in light years, where 1 light year is a distance a light travels in 1 year. The speed of light is 3.0 times 10 to the 8 meters per second. So for this problem, we're going to need a few things. We're going to need both the surface area of the star and then the area of the telescope. And then we're also going to need the energy in joules that we detect from the star and that the star is actually outputting. And since it gives us the joule energy in watts, we can multiply that by our 10 seconds that it gave us to convert our watts to joules. And once we have that, we know that our ratio of light will be equal to our ratio of surface areas, and that our flux equals our luminosity divided by our surface area, which for the star would be our 5.0 times 10 to the 38th once we multiply it by our 10 seconds, divided by our surface area, which the radius will just be our diameter here, or not our diameter, sorry, our distance from us to that star. So we can have our joules on the top and then our areas on the bottom. And you really just want to get this d by itself so we can solve for that distance. So just be multiplying the pi over, and then you just cross multiply here, you get these out, and then you can divide this side by our energy that we receive and our 4 pi, and you can equal d to the square root because of this squared over here of our energy multiplied by our pi divided by our 4 pi from over here, and then our energy that we receive. And you get your distance is 1.17 times 10 to the 24th meters. And since we need this in light years, which is the distance that the light will travel in a year, we know that our speed of light is 3.0 times 10 to the 8th meters per second. And to convert that to years, you just multiply by 60 to get to minutes, 60 to get it to hours, 24 to get it to days, and then by 365 to get it to year. And then you can take your distance divided by your speed of light in meters per year, and you can see that the star is 1.24 times 10 to the 8th light years away from Earth.